and we're going to see when it's listed, the input is always your first list of data, and your output is always the second list. So that I'm doing in the background of the video. So by that point, you will want to have printed out the activity so that you can follow along and complete it along with the video. This first week, doesn't happen to be one that's required. It's just the first one in the book, 1.1, and it's really just an introduction of functions. So depending on which O95 class you had or what your background is, you may or may not have discussed what functions are. So this first activity just kind of gives a brief introduction to that. So by the time you watch the video, you will want to have looked through the activity a little bit, read through some of these paragraphs. So I'm going to jump right into that first problem that we have here. So we have a set of data right here, okay, with a list of the time of day, the number of cars in a parking lot. Okay, so each slide in this, I'm going to switch slides, and that will be the next page of your activity. Okay, our input is going to be, you have to bear with me, I haven't made one of these videos all summer. The input is going to be the time, and then the output, what we get out of this, is going to be the number of cars for this situation. So the reason why we identify these is really for when we go to graph, which one we should put on our x-axis, which one we should put on our y. That's coming. It's not yet this week, but that's why we identify each of these. So for an input of 10, I'm not going to switch back screens because it will just kind of mess up the video, but for an input of 10, how many cars were in the parking lot? So if you look at that chart again, an input of 10 would give us an output of 426. That's how many cars. Okay. For an input of 5 o'clock, if I look at my chart for 5 o'clock, there where my output was 302 cars. So that's just looking at the chart. For each value in the input, how many different outputs? So when I look at that list of data that they give me, for each time of day, there's only one number of cars. Okay, it's not like at 8 o'clock there could be 212 cars or 150. Okay, for each input, there's one output. Okay, so each input, I'm going to use these arrows a lot, maps to one, and that one is important because that's when we're going to get into what a function is. That's what we need to figure out. Okay, so there they go. So now we're giving a definition of a function. A function is where each input goes to exactly one output. Okay, so it is a function when each input has exactly one. Okay, in other words, each x goes to exactly one y. Okay, so we go back to that x and y notation. Okay, so then it's saying how does this park problem fit the description? Because in there, each time, whoops, each time kind of maps to or corresponds to one number of cars. Okay, there's no time that's going to two number of cars. Okay, so now we're looking at another situation. Okay, this one gives us another list of data, and this one is a date and a high temperature, okay, during the first week of January. For this one. So you see next that they give us this same input-output as a table, and that's kind of, it's helpful to see, okay, that input of 1 goes to only 25. That input of 2 only goes to 30. So each input in there, you can look at the arrows, each input is only going to one place. So if D is the input and T is the output in there, then this does represent a function because it's one input going to one output. Okay, but what they have in this next table, if you look down there, they switched the input and the output and said, now is it a function? So if you make your temperature your input and your date, which doesn't really make sense to have it this way, but they're trying to just show that right here, let me circle where the problem is. This right here is the problem, okay? You see that 30, that temperature of 30 maps to two different dates. If I said, what's the date where the temperature is 30? Well, you would not know the exact answer because 30 maps to 2 and it maps to 7. That's why this is not a function. With the input the way it was there and the output being the date, then it's not a function anymore. Okay, so it does matter. So we're going to start to look at these as some ordered pairs too in a second. Okay, so they ask us to interchange the one in the parking lot situation. So if we go back to the parking lot situation, you would have to kind of scan down and see if there's ever two different times, looking at them right now, two different times where it's got the same number of cars, okay? And I see that if I switch it, okay, number of cars is my input, there's a 384, okay, that number of cars that happens twice. So that means 384 would be mapped to what times? 1 o'clock and also 7 o'clock. Okay, so this would not be a function. We would say that the time here is not a function of the number of cars. The other way around it worked, but this way it did not work. Okay, so let's see. Now we're just going to go through a couple more situations. So determine whether, in this case, the amount of postage for a letter. So I'm going to let you read through that because that's an example with a solution right there. And I'm going to go more to the ones that have things to fill in. So let's determine whether each is a function. So A, the amount of property tax you pay is a function of the assessed value. So the assessed value, that means this is your input. This is your output. Okay, that's how they're asking it. So they're really saying for each assessed value, is there only one property tax? And we would say yes. Okay, each assessed value maps to one or corresponds one tax. Okay, as soon as you get your assessed value, there's only one output. Okay, they say this is your assessed value, this is your tax. Okay, so each input goes to one output. Okay, so the weight of a letter is a function of the postage paid. Okay, so postage paid in this case, this sometimes is the hardest part. That's your input. That is your output when they're asking it like that. Okay, so this is the opposite of the one that they gave right there. Okay, so now the postage paid. So let's say you, for a stamp, okay, a stamp 49 cents. Okay, that postage paid could go to tons of different things. When we mail an envelope, maybe it is 2 ounces. Maybe it's 5 ounces. I know there's a cap, and at some point, if it weighs too much, you pay more. But this one postage could mean a lot of different weights. So we would say no, this is not a function. Okay, because we just showed that one input goes to more than one output. Okay, I'm going to let you try those next two on your own. And I'm going to I want to briefly, before the video has to be only a certain length for me to be able to post it. So I want to just stay within that length. So I'm going to scroll down and just look at, I want to skip this page, go through it. I want to look at writing some of these as ordered pairs, okay, so that you realize when you have an ordered pair, okay, which one is the input, which one's the output. So if you look right here, we have an ordered pair 3, 4 versus 4, 3. So those mean much different things. In the first one, the input is 3, output's 4. Second one, vice versa. So we just kind of looked at a couple examples with the parking lot and the postage for weight of a letter, that if you switch them, they are not necessarily functions anymore. So let's look down here. Okay, so I'm going to take a couple of those. I'm looking at number 7. So using a 24-hour clock, they're just having us write down a couple ordered pairs. So I'm just going to take, when they say 24-hour clock, they're just asking you for military time. Okay, so I'm going to give a couple ordered pairs. So if I'm looking at 4 o'clock, there's 278 cars. Well, 4 o'clock would be, okay, let's see, which one do I want to do here? Okay, so we'll do 1600. That would be 278 cars. Okay, so that would be writing as an ordered pair, input, output. Okay, 1 o'clock would be 1300. And that's where there were 384 cars. I'm just looking at that map, at that chart from the beginning. Okay, so they're just asking you to write, and we could do it for a couple more, but those are just writing that table as ordered pairs. Okay, I'm going to, for number 8, I'm just going to convert one of those to an ordered pair for that problem for the Lake Placid. That was the temperature one. So I'm just going to use the first couple. Okay, so date, that first day, high temperature of 25. So that's an ordered pair. Second day, high temperature of 30. Okay, and we could keep doing that for all of those. So we're slowly getting into function notation, which you may or may not have seen in the past. Okay, so when you read through this, I want you to make sure you're reading this and looking at this part right here. Okay, and how you read it. Okay, this would be said C equals F of T. So this right here, this T, that's always telling us what the input is. Okay, and then this right here is what we're getting out for output. So it's still really another fancy way of writing an ordered pair. Okay, so let me switch these. Okay, so these are taking a couple of the ordered pairs and writing them just in function notation. So I'm going to write the ordered pairs right underneath. Okay, so if I have this one right here, 212 equals F of 800, that means if I have an input of 800, I get an output of 212. Okay, so that was at 8 o'clock, there was 212 cars. This next one is saying if 302 equals F of 1700, that's saying if I have an input of 1700, so at 5 o'clock, there were 302 cars. Okay, vice versa, this last one over there, they switched the way they're writing it, but the 2100 is still the input. And that 187 is my output. So they're just another ways of writing ordered pairs. I'm going to jump down to this right here for this B. Okay, so write a sentence explaining the meaning of F of 1600 equals 278. So that means at 4 o'clock, that's military time, is going back to regular. 1600 would be that at 4 o'clock there are 278 cars in the lot. Okay, so this again is my input and this is my output. Okay, so I'm going to stop right there for this one because I don't want to go over the video time, but what I would like you to do is go back and do this last one right here, fill in the chart, and then practice using this notation, and that's what you're going to practice for homework. At the end of each one here, it gives a pretty good summary of the activity. Yep, even over here. So those are really good summaries at the end. And then you always have more exercises at the end of every activity. Okay, the one thing I want to point out is that these answers, not for the activity, but for the exercises, are in the back. So you use those as practice problems, and then you check your answers at the back. Okay, so let me know if you have any questions, but these are what the videos are going to look like over the semester. Again, some are required for you to hand in at the end, and some are just for you to follow along for the material. Okay, good luck.